Okay, in this video we're going to be multiplying and dividing surds. You've actually been doing multiplying for a while now, but remember when you do multiply, if the surd can be simplified, then you also need to simplify. So let's just start with an easy one. So question A, the square root of 7 times the square root of 3. And this is kind of the reverse of what you're doing when you actually simplify. The numbers under the square root sign get multiplied together. So 7 times 3 is 21. And just make sure that can't be simplified. So whether a perfect square can go into it. I know it's not divisible by 4 or 9, and definitely not 16. Okay, let's choose one that is divisible. So let's do D. Okay, so D is the square root of 3 times the square root of 3. So we're multiplying our 3's together. So we're left with the square root of 9. And the square root of 9, because 9 is actually a perfect square, is a 3. So you'll know that if you are actually multiplying the same surd, okay, so root 3 and root 3 in this case, you're actually just eliminating the surd in a way. So that just means the square root of 3 squared, okay, because we've got 2 of them. That's why they're squared. So the squared sign is the reverse of the square root. So that kind of all disappears and you're just left with 3. Okay, let's see if there's another one. Okay, so just thinking. Okay, so let's do K. So K, we have the square root of 12 times the square root of 8. Now you can simplify these surds before you multiply them. Okay, so there are 2 ways to do that. So let's do that first. The square root of 12, when you simplify, is 4 times 3, which is 2 root 3. And then square root of 8 is 4 times 2, and that gives us 2 root 2. So when we multiply them together, we have to multiply the number at the front. So 2 times 2 is 4, and then the number inside the square root is 6. So you get 4 root 6. The other way you can do it is to multiply your 2 numbers straight away. So 12 times 8. Okay, so 12 times 8 is 96, so the square root of 96. And then you're required to find the perfect square in 96. Okay, so that's going to test me. Okay, let's just think. I know 4 goes into 96, but it's probably not the highest. I know 16 does, just because I'm looking at the answer. So 16 times 6 must be 96. Let me just check my calculator. Yeah, 16 times 6. So see how it's a little bit harder? So you could be sitting there for a while doing this. So then we've got root 16 is 4 and then the 6. So you can see there's 2 ways to do this. I think the easier way is a lot easier, especially because you're left here with the square root of 96, and it might take you a while to actually realize the highest perfect square is 16. You could do divided by 4 and then do that again, but that's a long process. So I would advise you probably to simplify before you multiply instead of multiply and then simplify. All right, let's move on. Okay, so question 2 is basically similar to what I just did. So let's do, just trying to think what to do. Let's do D. No, I don't want to do D. Let's do G. Okay, so if we have 3 root 14 times 2 root 21, okay, so we multiply the number at the front, and the square root of 14 and the square root of 21 cannot be simplified. So we've got 6 square root of 14 times 21. Now, 14 times 21 is probably a bit too high for you to do by hand. So I'm just going to do it over here. 4 times 1 is 4, then 1, then 28. So 294. So a question like this you probably wouldn't be expected to do without your calculator. Then a number that goes into 294, this is where I'm going to cheat and use my calculator. First one I tried was 49 and it worked. So 49 times 6. Okay, so 49 is a perfect square, sorry. So square root of 49 is 7, and then we have root 6. So 6 times 7 is 42, root 6. There are probably other ways you can do it. So the 14, and I'm probably going a bit more advanced than what we need to be. So the 14 you can say is 2 times 7, and the 21 is 3 times 7. So effectively we can then multiply our 7s to get 49 times 6. So you can break it up that way to get your perfect square, but at year 10 you're not really expected to be able to do that. So I don't mind for this one if you do use your calculator, as long as you can understand how to actually do it. Okay, let's move on. Let's have a look at J. So J, we've got our negatives. Okay, so we've got -2 root 7 times -3 root 14, and that's just in a bracket. Now make sure you can realize that you're multiplying two negatives, so you actually get a positive. And then we have 7 times 14. And this is where it's handy. Remember when I broke up the 14 before to 7 times 2? So you can then rewrite this to be 49 times 2, which then gives you 6 times 7 is 42 root 2. Okay, but again, I don't mind you using your calculator to help you. All right, let's move on to question 3, which is division. And we've done a bit of division. I always prefer to write, whenever I see a division, is to write it like that. And that's just because if I need to do any cancelling, I can easily see what needs to be cancelled. Now, when you're doing division, you can actually take everything under the same square root sign. So if you're taking the square root of your numerator and the square root of your denominator, then you can take the square root of everything. And then you can simplify this fraction. So 20 divided by 2 is 10, and then we can just take the square root. And square root of 10 is its simplified form. You can simplify this square root of 20. So if we did it the other way, and then we've got 2 root 5 over root 2. The problem with this, and you're probably thinking, well, that's not square root of 10. It's because in maths, we do what we call rationalizing the denominator, which is another topic you'll do soon. When we rationalize the denominator, whatever third is on the denominator, we multiply it. So effectively, because the same number is on the top as it is on the bottom, I'm still multiplying by 1. I'm not changing it, but by doing this, I can get rid of the square root 2 on the bottom. Okay, so on the top I have 2 root 5 times root 2. So when you're multiplying fractions, you multiply your numerators, and then on the bottom we multiply the denominators. So 5 times 2 is 10, so I've got 2 root 10. And on the bottom, 2 times 2 is 4, so the square root of 4. And I'm running out of room, but that's all right because I'm going to fit it in. Square root of 4 is 2. So those 2's cancel out, and I'm left with the square root of 10, which is what we got here. So you can see either way will get you the answer, but you can see this is a much quicker way. The same for the next one, 18 over 3. So for B, instead of writing it that way, you can write it as 18 over 3, and you're taking the square root of everything. 18 divided by 3 is 6, so it's just the square root of 6. Again, you can go and simplify the 18, but you're going to have to rationalize the denominator. So the easiest way when you're dividing is to see if you can cancel before you simplify. Now, these ones here, all right, they're already written like that. So let's look at e, the square root of 15 over the square root of 5. Okay, that's the same as 15 on 5. And 15 divided by 5 is 3. So it's just the square root of 3. Okay, let's move down to the last question. Okay, so this time we have numbers in front of our surds, so they cancel out as well. Okay, so and this is why it's always good to write it as a fraction. So your 6 root 14 on 3 root 7, we do the integers first, so 6 divided by 3 is 2, and then 14 divided by 7 is also 2, so you're left with 2 root 2. And the same thing all along. Okay, so I don't need to keep going. The same thing. But just remember, when you're doing division, try to cancel before you simplify. Otherwise, you're going to have to rationalize the denominator, which can, the more maths you do, the more prone you are to make an error. So try to keep things simple. And when you're doing division, much better to write it as a fraction, cancel where you can, and then do your simplifying.